Because of pen issues, I'm not going to be able to write on this, but I'm going to go through very quickly in real time this exam. People have started to retake it, which is good because it should be much more straightforward now that you've been working in Civil3d. So, name 3 general rules for naming layers, files, or directory structures, some front-end loading to them, no spaces, numbering, capitalization would be a number of them. Some front-end loading is the key one, and underscoring is the other one that's key. Numbering as well, based on, and naming based on some logical sense, especially for offsets. Metadata is data about data. In civil design, where did your points come from? Where did your line work come from? That's metadata. Number 3, false northings, false eastings. That's why all the numbers are so odd between different coordinate systems. False northings and false eastings. So you do that when you set up your coordinate system by default. Horizontal design constraints. For instance, where you're hitting the road, where you're missing the tree, where you've got to get exact for a particular driveway or for an offset for a sign. So horizontal design constraints are things that in real space are going to constrain where you put your things. The most obvious ones are the perpendicularity at intersections, which lead, of course, to vertical constraints as well. A legal boundary is actually a description of land. A surface boundary is a line in a Civil3d drawing which defines the edge of some data that you've defined. In a left-hand coordinate system, left hand is northing, easting, elevation. Right hand is x, y, z. Pull out your hands and do them. A left-hand coordinate system, clockwise is positive. In a right-hand coordinate system, counterclockwise is positive. You need to now be able to delve into both of those worlds, sometimes in the same project. Station equation relates the location along 2 stations, or along 2 center lines. Usually we're using it at intersections. We also can use it when we change an alignment, so we don't have to renumber everything. Remember, 1 to 2 means 1 horizontal, 2 vertical. So this would be 1.5 feet. 2 to 1 means 2 horizontal, 1 vertical. That's key to civil. It's not always written out. If you go around a curve, you remember that the tangent distance is equal to r times the tangent of the delta divided by 2, which means that if you go around 4 curves, you essentially have a square that is 8r, r as a length if it was straight, and 2 pi r. And so this turns out to be 8 minus 2 pi in parentheses times 200 feet, since you are doing effectively going around in a full circle. You lock down your horizontal design very early for a number of different reasons. Predominant is, amongst other things, property acquisition, but also because of the alignment, the distance, the stationing. There is a reality that you could start thinking about things in terms of percent down the alignment if you start shifting your alignment, and that could keep most of it together. But as a rule, you just lock it down, figure out your horizontals as early as you can, and then deal with station equations if you need to make changes. Horizontal is to a circle as a vertical curve is to a parabola. You have to realize that we need to train our brain to read profiles at x and y times 10 or divided by 10 as the case would be, and so you need to be able to learn to shift the decimal place as you need. So that would be station 1020, elevation 1040.4. You have to at least learn how to use some form of scripting in the world, and so when you are doing planner work, profile work that's best done with the comma command, because the angles don't work there because you've scaled everything up by 10. So in this case, you're going from station 1000, elevation 1092.34. You're going 300 feet in the right direction up 9 feet, or 3%. Keep on going. In this case, we're doing something in the planner view, and that's why I would recommend you do things by angles. And so the first angle is your angle from the standard X position, and so this is 300 feet at an angle of 45. So that would be in effect a direction of northeast, but 300 feet. Distance, angle, angle. It's pure polar math. In this case, cross sections are at 1 to 1, so that is going 12 foot to the left, and it's going down 0.36 feet, or once again 3%, as we talked about before. So when you do cross sections, everything's at 1 to 1. In profiles, it's 1 to 10 and 1 to 1, depending as the case would be, 1 to 40, 1 to 4. Okay, we just talked about that. So for a profile, the Y is scaled up 10 times, and in a cross section it typically is not. These can vary, however. Civil scales must be read on a civil engineering scale, 1 to 10, 20, 30, 40, 50, 60, all the way back up to 100. And then basically for plans and profile, 1 to 10, 1 to 1, 1 to 20, 1 to 2, 1 to 30, 1 to 3, 1 to 40, 1 to 4, 1 to 50, 1 to 5, 1 to 60, 1 to 6. 18, catch point, slope intercept, daylight. You will see those coming at you in many, many different forms. So get those three and learn them as interchangeably as you do potato and potato. Things that go into a Civil3d structure that go in a corridor are a horizontal alignment, a vertical profile, and assemblies. Regions, of course, break the corridor up. And the most common difference between two regions would be either the targets, the assembly, and gapping, and the frequency, how often you want sections cut. We make it more frequent when you want to get definition. Number 21. A polyline is very, very, very powerful. So learn what it does and how it acts, and learn its difference from a line and a polyline, and especially from a 3D polyline. Those are different entities. A polyline and a 3D polyline are not the same thing. Horizontal data, I want you to carry around the northing and the easting of the point of intersection, and then the radius of the curve. That's because of the centripetal force calculation of v squared over r, and also sense of just being able to think in tangents and then pull back your curves based on what you learned for external tangent. For a vertical curve, station, elevation, and either the k value or the length of curve. You have other values, r and the like. Almost every subdivision ordinance will talk about k's. You should learn the relationship between the different ones, but in Civil3d it comes up and asks for a k or a length of curve. 24, concept of clear zone is an area just outside the shoulder where in fact you want to keep things clear and safe, so if a car goes off the road it does not result in a fatality. What is the floor slope for a rollover slope? That would be 3 to 1. Is really, you get steeper than 3 to 1, you've got big issues. Most town roads, they'll talk about 4 to 1. 5 to 1 is great. 8 to 1 is pretty common for clear zone. Longitudinal slope is a 1 in 12. Misspelling on accessible there. Standard cross slope on a standard 30-inch curb that has a 6-inch head. That is 24 inches, and it falls an inch and a half. That's 6.25%. But learning that it's an inch and a half over 24 is perfectly acceptable. This calculation here, you have to think about up and down, where I said the the lot side of the sidewalks is 10 inches above the top of the standard curb, you then have essentially 4.5 inches for the rise in the curb because of how you cut a saw cut on a curb. So you have 4.5 inches plus 10 is 14.5 inches, but you would have dropped across the sidewalk as well. So you have to think about change in Y and change in X. And the fact is, things can get very steep very quickly if you only have a 5-foot wide terrace. That sidewalk, you have to realize that you're dropping, if you assume a 1/4 inch per foot, you've only dropped 1.5 inches across that sidewalk. So in effect, you have 10 plus 4.5, so that's 14.5, and you'll only gain around 1.5 inches, so you have 13 inches over effectively 5.5 feet. So 13 inches over 5.5 feet would be the slope. I'm not going to calculate it here. You can calculate it and draw the picture yourself. Maximum allowable cross slope on a sidewalk is in fact 4%, 2% recommended. Where do you find a river? Anytime you have a long unbroken grade. Where do you find a pond? Anytime you have a sag curve. And when do you have a dam? Anytime you have done a fill section and you had something coming across, you've kind of cut off drainage with your road. That requires usually a surface drain outside at the edge of the on the slope intercept line. 1% is a pretty good rule of thumb for mass grading on asphalt. If it gets flatter than that, and sometimes needs to, you'll tend to get puddles, which aren't the worst of all worlds, but owners generally don't like them because of icing problems. Minimum allowable longitudinal slope on the DOT is 0.3%. Remember, we talked about 4 inches per 100. 0.3% is not 3%. It is not 30%. It is not 0.03%. It's 0.3%, or essentially what we talked about, around 4 inches per station or per 100. And finally, then, we have to know that we can do a Pythagorean theorem on this and take the square root of 6 squared plus 4 squared to get something like 7.2%. So that's 33 questions. Once again, you have a stab at this again. I would really take advantage of this. I will allow one other, just one retake of this one. You should do much, much better than you did in the past. And you should be able to do it quickly. There are very few calculations on this. Thanks for listening.